Hello everyone, we're continuing activity A, one-year analysis for the GMOs and the environment. Okay, so we are currently, we finished up number 4. This was some of the data that gave us basically the best value based on the resistance type. All right. Remember, if it's like within a ton, if you change numbers around and the yield's within a ton, it's not like a huge difference. But if you can get it more than a ton difference, it's a big deal. So if you look at number 5, when using caterpillar resistant corn, so right here, does it help to add insecticide? No, we added no insecticide, no herbicide. We still got the best yield. Why? Because yields, or the amount produced, does not improve when insecticide is added to caterpillar resistant corn. All right, it's already caterpillar resistant corn. So this strain of corn is already genetically modified that it can be resistant to caterpillars for eating it. Number 6, challenge. Try to maximize corn yield without using any chemicals at all. Which resistance type did you choose and what was the yield? So if you did caterpillars or caterpillars and herbicide, the yield gave you around 10.2 tons. All right. Without any chemicals at all, that's right there. Boom, boom. 7, observe. Clear any data in the table. Select the herbicide-resistant corn. Okay, so we'll do that right now. Okay, so we're clearing. We are clearing everything. Let's reset everything. Okay, so number 7, select the herbicide-resistant corn. Boom. Okay, so this corn strain, the genetic modifications that are made to this corn already has herbicide as being resistant. You're going to slide that to 300 liters per hectare. Starting with no insecticide, run several simulations, adding an additional 20 liters per hectare insecticide after each simulation until the maximum is reached. Okay, so we start with 0, play. Okay, we have 9.8 tons. Reset, it says to increase 20 each time. Play, 9.4. Reset, increase another 20. 20 plus 20 is 40. Good job for doing that math in your head, you super smart kid. Now we're up to 9.7 tons per hectare. Reset, now we're going up to 60. Run the simulation, 9.3 tons. What are we noticing? We're noticing a little bit of a trend here. Let's reset. 20 plus 60 is 80. I know you did that in your head. 9.5. Reset. 60 plus 20 is 80, plus another 20 is now 100. 9.0 tons per hectare. Hopefully you're seeing the trend. 9.1, so not much of a difference there. Nothing noticeable. Probably if we had more time, we would just run this a bunch of times. Oh, wow, look, it went up to 10.2. Wow, now it's up to 11.9. Big change all of a sudden. So you got to run the simulation all the way through just to see what's happening. 13.7 tons per hectare. All right, so number 7, it says switch to the graph tab. Graph, click. Change the drop-down menu on the right to insecticide. Boom. Describe the shape of the graph. So if we look at this, the corn yield stays about the same until 120 liters per hectare of insecticide, after which it steeply rises. Pretty crazy, right? Because here a couple of times it looked like it dipped, but then once it hit 120 or so, it started to increase dramatically. B, what does the shape of the graph indicate about the amount of insecticide needed to be effective? A large amount of insecticide is needed to be effective. Below that amount, very few caterpillars are killed or affected at all.